Good afternoon, I'm Luis Perez.
I'm Daniel Perry.
Okay, the first thing we want to do with this problem is find your areas for all your components. Luckily here, we have two components, 1 and 2 that are the same, 3 is different. So you're gonna get one area and use it for both, 1 and 2. The first thing you want to do is do 8 times 0.25. That'll give you 2 inches. For the bottom piece, you want to do 8.25 times 0.25, and that'll give you 2.125 for your area.
The next step is to find your Y-bar, your elastic neutral axis. What you're going to do for that is you're going to take your area of the two sections, 1 and 2, and multiply that by the distance to get to the center of them from the origin, and then you're going to divide that by the total area, and that's going to give you 2.81 inches.
Your next step is going to be finding the centroid, C, and that's going to be provided by doing H minus Y bar, and that's going to be 8.25 minus 2.81, which is going to equal 5.44, and that's going to be somewhere in this vicinity here.
The next step is to find your moment of inertia. Your equation is going to be a dy, so you divide it, or a dy cubed divided by 12. And so what you're going to do is you're going to have two separate parts of the equation here. You can double up on this part of the equation because these two arms are the same. When you multiply all that out, you're going to end up with an inertia of 43.56 inches cubed.
The next part is a little bit tricky. That's where you find your little a for 1/2 of the area of the top, and then the bottom half of the area on the bottom. What you want to do first is combine both of these pieces and multiply them by the width, which is 0.5. And once you put it in that equation for your area, it's going to be 6.12, which you got to do by first dividing your total area by 0.5, and it's going to give you that. So like I said, you got to find your A top, which is 6.12 times the width, and that'll give you an area of 3.06. The next step is to find your little a at the top, which is going to be given by doing your area over 2, which is going to give you 3.06, which is this distance from there to here, the halfway point.
The next step is to combine these bottom two pieces over into an easier shape. And so what you're going to want to do is break it down into two sections. You're going to have the area for this upper section of the bottom half. It's going to be 0.5, as you have both these widths, times 2.56, which is the remaining section, minus, or 8.25, the total, minus 6.12. That'll leave you with 1.28 inches. For the other little a, to get to the centroid of that, you're going to take your 1/2 or 1/4 of an inch and add it to 1/2 of 2.56, and that'll leave you with 1.53. And then to find the area 2 of the bottom, that's going to be for this section over here. You're going to take 8.5 times 0.125, that's to the center point from the origin, that's going to leave you with 1.06, and then to get your center point, you're just going to do the same thing there and get 0.125 inches. And then we got to do this still.
Okay, so the next step is going to be finding your Z, which is kind of confusing here because both of the numbers, your area, it's 3.06, and your distance, it's 3.06. So when you put them in your equation, Z is going to be equal to 28.94, and then you can explain the shape factor.
For the shape factor, all you're going to do is take your Z and divide it by the S. Your S is 8.27, your Z is 28.94, leaving you with 3.5.
My is simply going to be Fy times your S, and your Fy is given, it's 50 KSI times 8.27, that's equal to S, and it's going to spit out 413.5, and you want to divide that by 12, so it can be a kips per foot number. It's going to be 34.42.
And then the next step, your final step, is to find MP, which is just Fy, that given of 50 times Z, which we just found, 28.94, that gives you 1447. Divide that by 12 to get it into kip feet, and you're left with 120.58 kip feet.
And that will be the last thing you got to find for this problem.
That's it.
So thank you very much for this opportunity.
Thank you.